with the reference angle here. And we're going to kind of, I want to build off of this with the 30, 60, 90. So if I say that this is going to be theta, and this is 30 degrees, in a 30, 60, 90 triangle, what is opposite the 30? X. I'm going to call it, instead of x, can I say it's 1?
Yeah.
All right. So opposite my 30 is 1. What's opposite the 60?
Wait, isn't that y? The opposite of
Root 3. It's root 3.
Sorry.
And I'm getting there. And what is your or your hypotenuse? 2. Everybody okay with that?
Yeah.
Now, Lance, what is my ordered pair? What is the ordered pair for the terminal side of theta? What's the ordered pair here? Root 3 and 1. The x value, root 3. The y value is 1. Okay. So that ordered pair there would be at root 3 and 1. Now, what I want to look at is if I move this around and I duplicate this triangle, let's see if I can get this to work right. Yeah, look at me now, huh? So theta's still at 30 degrees off on that side. What now is my ordered pair? Root 3 and 1. Because the only thing that's changed is my x value went the other direction, didn't it? The y value stayed the same, right? So here's what I want to look at. Coming up, what is this angle measure here? I'm talking in terms of degrees. What is that angle measure there? It's 180, okay? Now, in order for me to decipher what is going on here, I needed, what we just did is found a reference angle. We just found a reference angle for the angle of 150 degrees. What we did there is that by moving our 30, 60, 90 triangle to the next quadrant, all we did was take 180 and subtract it out to 150 to get the reference angle. What happens here is reference angles are going to be angle measures that are bounced off an axis. Okay. These are going to be reference angles are going to be ones that are angles that are bounced off of axis. And the reason we work with reference angles is because they're going to mirror quadrant 1 trig functions. The reference angle is always going to mirror your quadrant 1 trig. So when I have special right triangles, if I know how my ordered pairs work out here, they mirror themselves into all other quadrants, knowing how far something is bouncing off an axis. Here's how this works. When I'm in the second quadrant, my angle is always going to be, my reference angle is going to equal 180, and we're going to call this angle minus theta. Okay? Theta is going to be from 0 to the terminal side in that quadrant.
Is it always a cube?
The reference angle? All right. Excuse me. In the third quadrant, this is going to be my reference angle now. Oops. how would I figure out what that reference angle is using 180? If I'm calling this one theta now in red, the red reference angle would be what?
360 plus 30. 180.
Well, hold on. If I need to figure out this value here,
I would be
Theta
180
minus-
plus theta minus 270.
so the reference angle in red is going to equal theta minus the 180.
Yeah.
For example, if this is 200 degrees, it's past 180, right? If I subtract 180, it tells me how far I bounced off that axis. That tells me my reference angle would have been 20, right? Then if I'm going this far, then I'm also going to bounce off my x-axis. What would the reference angle in purple be then? I don't know whether you can see the purple.
Oops.
Still need theta minus.
Theta minus 270.
Oops, I should move that this way. I should start here. How far off is it from there? Well, if I'm subtracting 270, that's going to get me over here.
Theta minus 360 minus theta.
360 minus theta. And I have this all written out. The book did a really nice job of explaining all of these quadrant stuff in both degrees and within radians. Now, this is going to happen both ways. When we're working with quadrant 2, we've just talked about this. In quadrant 2, your reference angle, this reference angle, was 180 minus theta. If it was in terms of pi, it would have been pi minus theta. Okay? If it's in the other one, in quadrant 3, theta comes all the way around. It passed 180 degrees. We got to figure out how to come back up to it. So we take theta and we subtract 180 degrees. Or we take theta and we subtract pi. How far have we bounced off that x-axis? I want you to remember when we're talking about reference angles, you're bouncing off the x-axis. Okay, you're bouncing off the x-axis. And then lastly, when you're in that quadrant 4, just like you guys said a second ago, as you're coming all the way around as theta into the 4th quadrant, in order to figure out what your reference angle becomes, how far are you bounced off the x-axis, you take 360 and subtract your theta. That tells you basically telling you how much you have left to get there. All right, how much you have left to get there, or 2 pi minus theta, because you've got to go all the way around. All right, that's how this stuff works out. So depending upon what quadrant you are in, that's why it was important to be able to visualize what quadrant you wound up in, whether you were within degrees or within radians. That's why we did a lot of drawing of angles. Now you're going to be able to figure out how far you need to go or how far you got to go back to get to the x-axis. Because the reason was that 30, 60, 90 triangle, this 30-degree reference angle, all of their ordered pairs are the same. The signs change. Once you understand one quadrant's worth of ordered pairs for your specials, everything else just falls into place. And it's just a matter of understanding what other angles match it. That's all it works out to be. You're going to use a property of a rectangle going across with changing of your signs. Remember a second ago we said this was it root 3 and 1?
Yeah.
Here it was negative root 3 and 1. Here it's going to be negative root 3, negative 1. Here it would be root 3, negative 1. It's just moving itself around within the 4 quadrants, mimicking the ordered pairs on that terminal side. Okay? It's going to mimic that out. It's crazy, isn't it? It's not that bad, I hope. We'll do this, we might do this for a day or two. Look at us, we might be in a section for 3 days. Isn't this crazy? Never happens. So let's take a look at this. Really easy example. 120 degrees. Everybody agrees that 120 degrees is going to wind up in the second quadrant, right? Okay. So if I'm going to draw out 120 degrees, the reference angle is how much does it take to get down to the x-axis? 180 minus that. What do you get? 60. So the reference angle here is 60 degrees, which means that 120 degree angle is going to mimic all the properties of a 60 degree angle within the first quadrant with different signs. And I mean S-I-G-N, not S-I-N-E, okay? It'll be different positives and negatives because it's in a different quadrant. S-I-G-N sign?
I wasn't listening, and then I heard S-I-N-G, and I was like, what is going on?
What I'm saying is that the sign S-I-N-E, like trig function sign of 60 in the first quadrant is the same thing as it is in the second quadrant, but the S-I-G-N, the positive or negative of it, changes. Trig. All right. Sign. It's actually spelled that. And then, but cosine, how do you know that spells cosine? All they did was just cut them off so they could fit on a calculator. That's it. Okay, that's the only reason. All right? And I'm talking about the sign, the positive or negative is what I'm saying.
Yes.
So that's what I mean here. It's kind of like the old, and I think I've asked a couple of you literary type to write out the following sentence. There are 3 twos in the English language. How do you write that?
Carefully.
You can't.
Carefully.
You can't. It has to be that verbatim. You cannot write it.
Unless you do like.
Nope. You have to say those exact words. How do you know which one to use?
But you can do like what it sounds like.
You can
You
do
can't.
T,
You have to have.
T, parentheses.
No. You can only have those words in it. Nothing else.
Like how you.
They're all pronounced the same, like you
Just put it number 2.
Anyway, so let's look at it in terms of, what would this be? 5 pi over 4. Let me show you an example in terms of radians. Yeah, radians. 5 pi over 4. Is that more than 1 pi?
Yes.
So what quadrant is it going to be in? It's going to be the third quadrant. This is the same thing as saying 1¼ pi. All right, everybody okay with that? How did I do that? Oh, don't worry about that sentence thing.
I figured it out.
It's a rhetorical question. There's no correct answer to it.
I have the correct.
All right, I'll look at it. Again, if I'm talking about 5 pi over 4, I'm coming over this way. So now that means my reference angle has to go here. What is the reference angle of 5 pi over 4? Pi over 4. You take, again, you take 5 pi over 4, and you're going to subtract out pi. In this case here, I'm subtracting 4 pi over 4 to keep the common denominator. And what's your reference angle?
45 degrees.
Pi over 4. I don't know what this 45 degree thing is.
It is what.
But I'm in radians. I gotta stay in radians.
Can't you convert when you go back?
Why? You'll never have enough time to do anything.
Well, you can do that one in your head because you know it's 45 degrees.
I agree, but when we start to get into a lot of this other stuff, you're gonna have to be able to maintain radians. Okay? Next year, Mr. Thames will beat me up if I don't have you guys.
I'd like to see that.
I would too. I would. Yeah. You guys have to. One of the things that is unbelievably stressed is the fact that you guys were going to be working with solely radians. I think they just started their trig section in pre-calc today or yesterday, and I heard him when I was walking by once saying they were doing a little bit of review in terms of degrees about reference angles, and they said, no more, we're going right back to radians because everything else is going to be done in radians. So we got to pull the Band-Aid, rip it off as fast as humanly possible, and we're going to be okay. Just terms of pi.
Can we do another example?
Everybody likes pi.
I hate pie.
Oh, I'm sorry.
Make his pie.
Well, no, I like real pie. I don't like pie.
All right, well, let's look at another one. I want to get the reference angle for 7 pi over 4. I want to get the reference angle for 7 pi over 4, which means I got to first of all figure out what quadrant 7 pi over 4 is going to wind up in. This is when you ask yourself a very simple question. How many times is 4 going to 7? How many are left over? 3. 3/4. So I know that if I'm going around 1 pi, here's a half a pi, here's the other quarter pi. What is the reference angle for 7 pi over 4? Right, so pi over 4. Your answer is pi over 4. A real easy thing to think about here is
How
that
did you
you,
get pie over 4?
because you want to get to 2 pi.
Yeah, I got
Remember, you want to get to 2 pi here. 7 pi over 4 is 1 pi over 4 away from 8 pi over 4. Otherwise known as 2 pi. Okay? It's just a drill. First day of meteorological spring. Tornado sirens are going off.
That wasn't the first.
Well, I know, but it's the first Tuesday after meteorological spring. How's that?
Tuesday and Wednesday.
It's spring.
Yeah, I know, right?
On Tuesday.
2 more. Radians. Again, when I'm working with radians, 7 pi over 8. When I want to think about 7 pi over 8, it's obviously less than 1 pi. Does everybody agree? All right. So if it's less than 1 pi,
So wouldn't that be like 1?
how much more do I have to get to make it a pi? Pi over 8. So the reference angle here would have to be pi over 8 because it's that far off of the axis.
Oh, I answered pie over 8.
Yeah. He couldn't get away from the buffet.
Ah.
Nothing.
Pi over 8.
Yeah.
I
Anyway,
like that.
dude, I never said I was funny, okay?
Yes, you did.
That
Yeah,
was
I tried.
bad.
It was very bad. It was not funny. 2 pi over 3.
So would it be
1
pie
pi.
over?
Or 1 pi.
Pie over 3.
2 pi over 3. What quadrant is 2 pi over 3 going to be in? It's
That
the
one.
second quadrant again. 2 pi over 3 is over here. How much more pi do you have to get to the x-axis? Pi over 3. Does this change if it's negative? No, nothing. It doesn't change if the values are negative. You're just going the other direction. Let me show you. Remember, the direction of the negative degree or negative pi is just, you're just going the other way. Okay? Let me show you. If I'm talking about negative, if I'm looking at negative 120 degrees, I'll go back to degrees because you guys tend to like that better. Shh, gentlemen, come on. It's going this direction. What quadrant are you in? Third. So if you're in the third quadrant, wasn't that theta minus 180? No, yeah. So to bounce back up, it's still 60 degrees. You have to remember when you're negative, you got to flip it around. Here's,
It wouldn't be negative 60.
I don't remember if this book tells you to go negative on this one, because you're not looking for negative angles when you're working with sine and cosine, because the reference is still 60, to be honest with you.
Can you just make it positive 120 and then, because otherwise it would be shifted.
Yeah, you want your reference angles always to be positive. Okay, your reference angles are always going to be positive.
Can you just make it positive or show negative there, which makes it, like if you have a negative angle, that you make the number positive.
It's still going to give you the same reference angle. It'll still give you the same spot. You're still looking how far you're bouncing off.
Are we ever gonna have the ones where it's like, 780 degrees? That doesn't work, that just,
Yeah, because you can still spin it around. You can have like a 700 degree.
just practically 60 and then go from there.
Yeah, you're going to get the positive coterminal angle within one revolution, and then get the reference angle off of that. That's why I was stressing to get it within one revolution prior. Okay. All right. Again, reference angles are going to be positive. How far are they bouncing off the x-axis? We're really not going to have time to do the rest of this stuff.
I'm sorry.
Here's what I want you to do, because there's absolutely no way we're having time to go through this. Will you guys stop? Come on. Keep your hands to yourselves. Stop messing around. Okay? It's really disruptive. The next big part of all of this is where did all of the ordered pairs come from on the unit circle? What I would like you guys to do, as well as the homework stuff here, is I want you to, for the first part of your homework tonight, is just take out your sheet, and I want you to draw a 45, 45, 90, and your 30, 60, 90 triangle. And what I want you to do is write it out. Remember how we wrote this before? It was 1, 1, in root 2. And this was 1, root 3, and 2. What I would like you to do is make a table for your 30, 60, and 45s of your 6 trig functions. What I want you to do is to kind of draw that out, and I want you to fill in the blanks of the 6 trig functions of the special right triangles. When we get through working off of that, that is where we're going to see how the reference angles work within the unit circle. The unit circle itself that we've already drawn up is based upon the 30, 60, 90, 45, 45, 90. Those ordered pairs, the x's and the y's, remember, it goes cosine and sine. That's where all of that came from. So please write that out, as well as, I think there's 8 reference angle problems I'd like you to look at. The reference angle ones are on 788. It's 37 to 44. That's really all there is going there. All right, yes, sir.
So those angles in the table are all going to be faded.
Yeah. So what is that? 788, 37 to 44. Yeah. It's just those 8 problems as far as generating reference angles. Sketch the graph of where it is and then figure out what quadrant you're bouncing into. Reference angles are going to be positive. All right? Now, again, this whole idea of where everything is coming from is that I know when I'm looking at 30 degrees, if I want to know what the cosine of 30 is, it's opposite over hypotenuse. Or excuse me, sine of 30 is opposite over hypotenuse. So the sine of 30 degrees would have been 1/2. The cosine of 30 degrees was √3/2. What's going to happen here is if you look back at your unit circle, as this got shifted over to the second quadrant, the only thing that changed was your cosine value. When it went down to the third quadrant, they both became negative because it was just mirrored itself through. When it got back to the fourth quadrant, the only one that became negative was the sine value because it is in the fourth quadrant and it's the y value.
Wait, how can you run out of the tangent?
Where we'll get to the tangent, the tangent isn't shown on the unit circle because it doesn't have its own ordered pair. The tangent's just going to be found as 1/2 divided by √3/2. You're going to be multiplied by reciprocal. You can solve the tangent, but you don't need the ordered pair for it because it isn't a specific ordered pair. Now, what's going to happen here is your next angle up, your 45, will also have those same ordered pairs going all the way around. This 60-degree angle, same idea. You're using properties of rectangles to build off of all of that. Many students freak out, and Mauro, you might attest to this, because I know you saw the unit circle for the first time this year. When you first saw it, but now that you've worked with some of those problems, you see how easy it is. Once you understand where the 30, 60, 90, 45, 45, 90 mirrors itself in, it's nothing more than knowing what quadrant is positive and which quadrant is negative. Reference angles get you to all of those values. Okay? Am I missing any on that, or is that basically the easiest way of remembering? Not so bad? It should be all right, okay? Tomorrow, we're going to go through, and I'm going to take away your calculators, and you're going to find all of that by hand.
In radians?
In radians and in degrees via your unit circle. You have to understand how to build it. And that's where all this goes from.
What do you even do to find
What is the cosine of 315 degrees? So what's the reference angle for 315 degrees? It ends in a 5. What do you think it's going to be? 45. So what is the cosine of 45 degrees? Cosine of 45 degrees is adjacent over hypotenuse. So it's 1/2, right? But cosine, is it positive or negative in the fourth quadrant? What is the x value in the fourth quadrant? 1/2. Positive, so it's 1/2. Cosine of 315 would be 1/2. It's all built off of references. Yes, sir?
Can you go through what you just said one more time?
We'll do that tomorrow.
Can you just say exactly what you just said?
Yeah.
Why did it be 1?